Standard deviation. Oops. Standard deviation is, it's a friend of the mean, I say. Standard deviation is friend of the mean. It goes along with the mean. To just say the average, like if people said, oh, the average is 90% on the test. If you also say the average is 90% and the standard deviation is 10 versus the standard deviation is 1, that tells you a little bit more information. The standard deviation, which the symbol is like this little 0 with a tail on it, explains, it's kind of not the right word, but explains like how spread out the scores are. A high standard deviation means scores are really spread out, and a low standard deviation means that numbers are more clustered, we say, to the mean. Now, you want to say a little quick thank you that it's not 1996 anymore, because back in the day, we used to have to use this formula by hand, and kids would have to memorize it, and they would have to memorize this process of finding the mean and subtracting each number from the mean and squaring it. The mean, by the way, is x bar in here. xi is the each term. We add those numbers up with our sum symbol, divide by the number of numbers, and then take the square root. But lucky for you, we can do this all on the calculator. So here's what we're going to do. We're going to hit the stat key, and you're going to hit stat, and then edit. And then you can type in your numbers, and it'll say like L1, list 1. Then once you have your numbers typed in, you're going to go back to stat, and you're going to go to calc. And then you're going to choose one variable stats. And once you do that, you hit enter 3 times. Enter, enter, enter. And then that's going to give you all the statistics for that data set. So if you do that, you'll see that one of the first things is x bar. X bar is the mean, is 7.57. That's the mean. And then a little farther down, you see a little 0 with a tail, and that's the variance. Or sorry, that's the standard deviation, 3.02. So I'll explain that in a second, what that number means once we look at this data set. If I were to do the same thing with this data set, type everything in, stat, edit, type in the numbers, stat, calc, one variable calc, stats, enter, enter, enter. I'm going to get a mean here of 41.3. But in the standard deviation, you'll see is much higher, 36.6. So now that we look at this, each one obviously had an average that kind of makes sense. But what does this standard deviation say versus this one? The high standard deviation says the data set has a lot of variability in it. It goes all the way from 6 to 100. Where this 3.02 says this data set is a lot more clustered together. And that's what the standard deviation tells us. High standard deviation means lots of variation. Low standard deviation, not a lot of variation. And if you're in any kind of manufacturing situation, you would want low standard deviation because you want everything to be the same. You want consistency, right? You don't want a lot of variance. You actually want the standard deviation to be 0. When would the standard deviation be 0? Right, when all the numbers are the same. When all the numbers are the same. And that's kind of the goal, right? When all the numbers are the same. So if you had a data set that was like 5, 5, 5, 5, 5, average would be 5, standard deviation would be 0, life is good. Once we get the standard deviation, we can talk about the normal distribution, or AKA the bell curve. And the bell curve says data is maximized at the mean. The x bar, the mean, is the point of the most data sets. So the data is maximized at the mean, and then every standard deviation that you go up, 1 standard deviation, 2 standard deviations, 3 standard deviations, there's a set number of percent of the data that's in that chunk. And this is just consistent over time. This is something that's observed in nature, so to speak. So let's say, for example, the mean, you surveyed students and you said that the mean number of hours that students studied for their final exams was 12. Data's maximized at the mean, so the 12 goes right in the middle. Standard deviation's 3, so that means you go up by 3 for each chunk. And then similarly down by 3. 9, 6, 3, 0. If you want, I'm going to do these problems from the bottom up. If you want to say what percentage of students studied less than 12 hours, that's all these kids, and those add up to 50% of the kids. What percentage studied at least 9 hours? At least 9 hours is from 9 hours and above. So if I would add those percentages up, I get 84%. What percentage of students studied 3 hours or less? That's my 0.5%. So I'm reading those percentages right off of the bell curve. If I want to know how many students, now I'm going to take the percent times, it said in the directions there were 200 students. So studied at least 3 hours, that's 99.5% of the students, so 0.995 times 200 is 199 students. How many students studied between 9 and 15 hours? That's 68% of the students, or 136 students. And less than 9 hours, that's what? Less than 9 hours, I think that's 16%. I'm just going to do that one here, so it's 0.16 times 200, or 32 students. So these percentages are consistent, and a normal distribution in school is grades, right? Especially when you talk about a standardized test such as the SAT or the ACT, right? How they figure out those scores is based on the bell curve. They find out the mean and they maximize the data at the mean. If you think about it in terms of letter grades, it might be that like this middle chunk of grades is like C's, and then B's, and then D's, and then A's, and then E's, where the data is maximized at the mean. So we'll talk about that more in class. You do have to know those percentages for the test, and that is the normal distribution.